Okay, our next presenter is familiar, I think, to at least some of you who are from here on campus. Is Dr. Jason Hubbart. Jason is an assistant professor in the Department of Forestry and also is on the faculty of the Soils, Environmental, and Atmospheric Sciences faculty as well. And Jason's going to speak on floodplain forests, flood attenuation, landscape connections, and energy solutions. Welcome, Jason.
Thanks, Mike. Okay, thank you. So I'd like to acknowledge Dr. Gold, Dr. Jose, and Tricia Oswald, and many others for putting together the symposium. It takes a lot of effort to do so. Thanks for the opportunity to be here today. I landed in Missouri in the fall of 2007, and shortly thereafter it started to rain. I was never happier. There was a lot of water to measure. I would walk into the department, down the halls, soaking wet much of the time, and get interesting expressions, but I was really happy. And then I realized that there were some problems associated with all of the water, that there were some things that I should, that other folks took quite seriously. And of course I did as well, but still I'm a hydrologist. I like water, so there you have it. I also landed in a watershed that happens to be 303D Clean Water Act listed. That means it's theoretically a polluted waterway. So in conjunction with flooding and a lot of precipitation, then you also got the potential for a lot of transport pollutants and so on. Coupled to that, of course, is the fact that we're also sitting in the city of Columbia. So a large percentage of impervious surface. So I started thinking about my background almost immediately when I got here. And in my background, I've had the opportunity to work on water regime issues related to land use, and in particular plant-water relations, forest harvest, and so on for almost 10 years now. I've had the opportunity to work in a number of different places with a lot of really smart people. And I've learned a few things and been continually amazed and impressed, I guess, at the value of plants in and of themselves to help mitigate, really inexpensively, cheaply, this problem that we see here oftentimes related to flooding and also in this case stormwater runoff. So increased water and plants can help to a great extent with that. I've also been impressed at what plants can do to soil to help increase the porosity of soils, the infiltration capacity of soils, and I'll talk more about that pretty quick. And I think that perhaps those really simple ideas that we're all fairly aware of may be underappreciated, and maybe we haven't capitalized on that simplicity as well as we could have, and hence that led me to start working in floodplains. And this is a flow diagram I started working on yesterday because I was thinking about all of the connections, and today, if anything, this symposium has told me that interdisciplinary collaboration is critical to make this work. And that the economic incentive part of my title, for example, is not something I have the expertise to do a lot about personally, but it's by collaborating with other folks that we can actually start to connect the dots and do something quite meaningful. However, to back up, I was faced with this problem, right? Remember, I was real excited about all the water. Well, we had problems associated with that. Flooding, as most of you are aware, is among the top 4 or 5 environmental disasters in terms of magnitude every year, and runs up a tally of almost $4 billion every year. It's real expensive. It can be a disaster, obviously. And is something that we're here to talk about today. So I started thinking about floodplain capacity to attenuate stormwater and flooding, because to me this seemed like at least a twofold problem. One, we had urbanization, impervious surfaces, and other we had this flooding issue. You put the two together and you have a mess potentially, right? And so I started thinking about, well, what's the capacity of a floodplain to attenuate or absorb water? Because floodplains certainly act like a massive sponge for water and runoff. And how much is that? If you're going to start selling an idea, then it would be probably a good idea to quantify that and to present real numbers to folks that you're hoping to create changes. And assuming that there's something to this, how can we then return floodplains to historic attenuation capacities? And of course, what I'll focus on today is the need then for quantitative research. But this leads to ideas about science-based solutions, and including how do we offset the mitigation costs for stormwater management, how do we improve floodplain and flood wave attenuation, how do we improve aquatic floodplain connectivity, and how do we create incentives for all of that to occur, which often is cut off from the science part. And it's something I've been thinking an awful lot about and trying to work with a lot of folks to get some help. Because it's the incentives to follow the recommendations that so many of us come up with based on science-based solutions, science and research that we do. It's difficult to get that into policy sometimes if you don't have incentives built in along the way to, for people to get motivated. As I mentioned, this is really a twofold problem to me. We could really make this complicated for today's talk. I'm going to keep this simple. And just suggest that this flooding issue is related to imperviousness, flashy hydrographs, increased runoff, and urbanization, the built environment. And of course also floodplain management and flooding. A lot of this has to do with forest removal, which I'll talk more about, channel straightening, channel incision, and there's a long list of other factors that we could discuss as well that don't have time today. I want to admit right immediately that I am well aware that the city of Columbia does not have beachfront property, hence the seagulls, but this was a good picture to get to drive home the point that I want to make, which is that in undisturbed systems we tend to have meandering channels, and we're all aware of that. What we don't think about often is that not only do we have a perpendicular flux of water from those channels, but also a flux of water between the meanders themselves. So this creates a relatively wide and mesic environment and a great deal of hydrologic connectivity within and around the system. And we often think of this as a variable source area for water that surrounds these aquatic ecosystems. And when you straighten these channels, and as this example shows, to dry out the land around it, to get it through an urbanizing area, then you lose that hydrologic and hydrogeomorphological connectivity. And we've done that on purpose, and it makes sense in many places, right? We want to get the water out, shunt the water out of the system, and drive the landscape around it so that we can access that land and do things with it. And I guess what I'm starting to try to argue is that maybe we should start thinking about going back to this situation here, this more meandering system. Take these areas back to what they were. We're talking a century, 2 centuries, and 300 years ago, perhaps. So this is all coupled, of course, this lack of connectivity, hydrologic connectivity, is coupled to this increased runoff problem with urbanization, and as we often see in the central United States, flooding associated with that. I think it's important to take a step back also and talk about legacy effects related to floodplain management. This was the first major wall that I ran into when I started to investigate this, was that there's a significant legacy effect with the way we manage floodplains, and in fact, ironically, the way we don't manage them. We manage floodplains today very much like we did a century ago, and even before that. And it all goes back to some major changes in the development of the country, including that in the 19th, 20th centuries, much of the bottom and hardwood forest was removed, largely for streamboat travel and transport, and also to cultivate rich soils of floodplains and to access those soils. Many of you may be familiar with the steamboat Arabia. There happens to be an Arabia museum in Kansas City. If you've never seen it, I recommend it. It's really interesting. This steamboat was found about a half mile away from where the current Missouri River is located, so in an old meander, buried in the soil. The point of this is that most folks don't realize that this paddle wheel on the back of the steamboat is 20 feet wide, and that this boat used about 100 cords of wood every single day. is it any wonder where the trees went? And you know, at that time, this was a win-win, right? That one, there was lots of fuel. You imagine, you know, driving down the road and there's just nothing but, you know, continuous nozzle to fill the car up, right? This is kind of the situation. There's just endless fuel supply, and the win-win is there as well, because then we get to clear the land and use it, you know, for agriculture, grazing, what have you. Well, in addition to that, drainage tiles, ditches, levees, dams were installed. And we should also realize that there were a number of similar inland practices that took place at the same time. And that's also important right here in this watershed, and important in many other places, where we get backwatering from larger bodies of water. The Missouri is no exception. We get backwatering from the Missouri River right here in Hinkson Creek watershed 2 to 4 months just about every year. And so that's backwatering from the Missouri about 8 miles inland. Well, that also allowed passageway for folks to get in and do many of these same things, right? Well, so the upshot of this is that in terms of management, the forest was removed, stream river channels straightened and enlarged, and this reduced the flooding and dried the soils. And at that time, that was a good thing. Well, the result, though, now, today, is altered stream and floodplain hydrogeomorphology, and that disconnection that I talked a little bit about. And of course, the problem that we see now is this reduced urban stormwater and flood wave attenuation capacity of that floodplain sponge. Okay, so not only is a floodplain able to act like a floodplain and absorb the flood wave, but it also is not equipped to deal with increased stormwater runoff from the built environment, impervious surfaces, and so on. And of course, also this is coupled to a surprising lack of floodplain management plans. Well, you know, how do you attack this big problem when the solution seems somewhat obvious? My approach has been to attack it from a number of angles all at once, and to collaborate as much as possible. Also, I should mention that many floodplain lands in Missouri in particular are privately owned lands. These are folks that have owned the land that's been in their family for generations, and are used to seeing that land look a certain way. So to suggest a change in philosophy in terms of the land use practices, that requires some work and background and an investment, I think. So the needed research included the following questions. What was historic floodplain water attenuation like? What is it like today? How do you maximize that attenuation to make you know, this idea of restoration plausible? How can we maximize that use to sell the idea? And how can you do that to sustain development? And by that I mean, you know, realistically, we can assume that the population will continue to grow, development will continue to occur, and we need to be managing the landscape accordingly. At the same time, we need to be creating incentives for landowners to grasp ideas that, while they may make a lot of sense and be altruistic to some extent, we need to still create incentives for folks to take a leap of faith or to embrace new ideas, such as what I'm going to be advocating, which is reforestation of floodplain lands. So my initial approach was a case study of the bottom and hardwood forests in an agricultural field. This is them. It's the bottom and hardwood forest, and it's an ag site right below the University of Missouri golf course. This is the ag site, and this is the forest site in the green. The forested site has trees dating back to about 1910, 1917. The ag site has literally been ag or pasture, some combination, for the last century. So these are two long-term study sites that have been used the same way, managed the same way for a very long time. Interestingly enough, this ag site has not been used for agriculture, but has been mowed about 4 times a year for the last decade. And I've asked why that is, and the response is because that's what we've always done. So there again, we get back to this legacy effect issue. These diagrams on the right, the top is 1939, 1992 below that, and 2010 below that. And this meander that is now gone was removed in the early 1940s by the current landowner at that time. Why? To dry up the land around it to be able to have better agricultural access be able to get out in the field more often during the year. Very, very common thing to occur, right? And very reasonable thing to occur at that time. But in any case, keep in mind that by virtue of doing that, we lose that hydrologic connectivity between that aquatic ecosystem, the terrestrial landscape around it, and therefore the floodplain attenuation capacity. So we installed two replicated grid designs at each site, exactly the same. And we've monitored leaf area index, infiltration capacity. We've done stem mapping, estimated basal area, looked at soil characteristics. We've quantified the characteristics, and there was also installation of 9 piezometers per site. The piezometers actually go about 1.5 meters below the stream bed to look at shallow groundwater flow. And I just want to skip right away to some of the results. And I want to focus just briefly on, I guess, the dominant number of individuals, including box elder, silver maple, eastern cottonwood, American elm, and then skip over to the right side of this figure to the total basal area. So we have the total basal area. This is, by the way, I didn't mention the plots are 120 by 120 meters. It said so, but I didn't. So there you have it. So 22.7 roughly square meter basal area in that bottomland hardwood forest site. That basal area was dominated by a few individuals, 12 east of eastern cottonwood, and also by a number of individuals of silver maple. There's an important story there. So we have few old or large trees, right? And more young and small trees. And we've got a young cohort consisting principally of silver maple and American elm. It's important to keep in mind that cottonwoods, as we're all pretty aware, and willows and other similar species transpire a lot of water, a great deal of water. These are plant-loving or water-loving trees for the most part, and transpire a great deal, and often more than these other species that seem to be propagating in that site. So there seem to be clear problems with reestablishment, and I attribute this primarily to this lack of hydrologic connectivity, that we've lost the meanders, the soil's not as mesic, it's not as it was, the riparian zone's not as wide, the conditions are not favorable to reestablishment of native species. That could be real important if we're going to really start to embrace this idea of floodplain forest reestablishment. We also did a number of infiltration capacity tests between the sites, and they were significantly different. About a 15 centimeter per hour difference between the ag and the forested site. I think what's most remarkable is these maximum figures where it's upward of 126 centimeters per hour. That's pretty massive amount of infiltration. And what's interesting and useful about these data is the potential use then for mitigating stormwater runoff. Currently, the city puts much of that stormwater in the ditch, and it finds its way to Hinkson Creek. Well, what if we could remove the water from the ditch and spread it out on the floodplain, allow it to infiltrate, make its way slower to the creek, hopefully take advantage of some bioremediative qualities, and do a bunch of good things on its way. And in fact, as I'll show later, I'm starting to do some work with the city on that. We've also looked at soil characteristics down to a depth of 100 centimeters. These results reflect that. The red lines are where the results were significant. Without taking the time to go over this whole figure, though, it equated to about an 11% difference in volumetric water content between the two sites. And that may not seem like a whole lot, but I'm going to come back to that number in a few minutes. I've also been starting to do some work with a current graduate student, Keith Brown, looking at evapotranspiration, and these are some preliminary results. We're actually using about 7 or 8 different models to look at ET, just to figure out what works best in the floodplain. These are the models that are behaving themselves at the moment, and I just say that because the results seem plausible. We're looking at, if we look at the BHF, the bottomland hardwood forest site, we're looking at roughly 3 to approximately 4 millimeters transpiration per day. That's pretty consistent with what you see in the literature. So that consumptive water use aspect is critically important, which I will also talk more about in a second. I've also been doing some work looking at that shallow groundwater flow with a former graduate student, and some of our preliminary results are pretty astounding and a little bit surprising. So I'm going to tiptoe around it a little bit until we've had more time to look at it. But what those results are implying is about a 30% difference in groundwater flow between the Bottom Harvard Forest site and the ag site. And there could be a variety of reasons for that, including the presence of woody roots, preferential flow paths for water into the soil. Whatever the roots are doing below ground, the porosity results, so the soil characteristics were significantly different between the two sites, suggesting that those roots do a lot of good things underground in terms of increasing that porosity and void space. So it's possible that we're seeing some of those that effect here. It's also possible that we have that the forested site in this study is subject to a little bit different shallow groundwater flow all by itself, and that there's actually water that's getting into it that maybe more water flowing through it in the first place. So this gets at the issue of replication of studies, which I'll admit to again later. So if we look again at this 11% difference in soil water over the 100 centimeters, and we can simplify that to the 30 centimeter depth because that's where most of the rooting zone is. That's a 5% difference between the two sites, which doesn't seem like a lot, but it's actually about 60 millimeters more water that's being held up in the Bottom Hardwood Forest site, at least during the period of this study. The implications for this in terms of potential consumptive water use are rather significant, I think, in that if we assume a conservative value of 4 millimeters per day transpiration, and that's well supported in the literature, and we know that willow species can transpire 4 to 6 or more millimeters per day transpiration, and this has been supported by pan evaporation data that we've acquired as well. So this, I think, is a very conservative, it's a safe number. That is equivalent to about 720 millimeters of consumptive water use per year, which happens to be about 2/3 of the total water budget. So this is substantial, and particularly so in urban watersheds. It's worth mentioning that this is obviously only going to be a benefit where you've got the forest land, right? This is not going to be something that covers the entire watershed necessarily, but floodplain forests have many different attributes going for them. One is they are often connected to shallow groundwater. They're not as water limited, therefore, and then theoretically those trees should be able to pump water full time, big time, all the time. So this could be a fairly significant amount. And to kind of get at this a little bit better, I did a little bit of work with another former grad student, John Nichols, to kind of look at, well, what does this mean in Hinkson Creek watershed? If we scale this up from the plot level, what does this mean? And so we looked at the 100-year floodplain and the 500-year floodplain. If we just take a quick look here, that equates to about 17.5 square kilometers of land area. And I did some back of the envelope number crunching just for today. So what that means is I'll back up. If we assume that half of that area is already forested, and my feeling is that that's being generous, but if we make that assumption, that leaves us with about 8.75 square kilometers. If we apply our 30-year average precipitation to that area, that gives us, if we just look over this number over here in the interest of time, that's over 3 billion cubic feet of water in a year. And multiply that times our transpiration rate, that's over 800,000 2,000-gallon fire trucks of water. That's a lot of water that could be consumed and transpired out of the watershed. I've also started looking at this another way. I had mentioned earlier, I'm trying to hit this from a number of angles. Well, how can, and one of those being, how can we maximize this environmental benefit? So what if we could just reforest with willow and poplar type species? And by virtue of doing that, we also are introducing a fuel source. This could also provide an incentive then for landowners. And I think there's a great deal of potential here. Of course, as in the last talk, this ended up being a study on drought tolerance last year. But I think we've had actually pretty good survival. But we'll find out for sure in the next couple months. So we back up a second here. Yeah, we actually implemented a willow study site, again, below the University of Missouri campus. The university donated the area and said, hey, come plant willows, so I did. Why not? This is Hinkson Creek along the bottom. And so the idea is to let it grow. We've planted the trees. We'll probably do some replanting this spring. We're going to install climate station and soil volumetric water content sensors and let it go for a few years just to look at that biomass growth, because I think that floodplains offer a more ideal, more mesic environment for growing willow biomass crops as well. And to look at the profitability then and eventually work with some other folks to get at those figures. I've also started looking at working with the City of Columbia, who have recently decided, hey, let's let this corner of the Forum Nature area reforest naturally. So there's a lot of ways to approach this issue. It can be really, really inexpensive. This is one way it can be really inexpensive. Just let it go back and do its thing. Let it grow the trees. So we're going to go back in and mitigate invasives over the next few years, and otherwise let it do its thing and grow a forest back. And we're monitoring it the same way as the other sites, looking at volumetric water content use and so on. The city is going to also install a vegetated swale and a level spreader. Level spreader will be used to get that water out of the ditch and spread it out on the floodplain and allow it to infiltrate. And you saw those massive infiltration capacity data. I think it can handle that job. And so this will be an interesting experiment to see how well that floodplain can continually provide that environmental service. In this case, stormwater runoff. So the work shows quantitatively the benefit of reestablishing floodplain forests, I think, to enhance floodplain storage capacity, attenuation of flood wave, reduces stormwater runoff, mitigating development and urbanization. I think there's a great deal of potential there. There's really useful, exciting implications, I think, for aquatic habitat restoration, water quality, inner city parks, human health, the list goes on. Obviously, there's a great need for more work. Isn't there always? And one of those is study replication. As I mentioned earlier, this was a case study that I presented today. We are actually starting to replicate some study sites, and I think that information will be very, very useful as we move forward. There's a need for modeling. We have enough useful observation data at this point that it's time to start doing some modeling, doing some scaling exercises to take a closer look at growth of biomass, potential for profit, for landowners, as well as ecosystem services. I have a feeling that it's the combination of usefulness of this practice that's going to sell it. It's by being able to do a number of good things all at once, as well as bring in an income, that I think that will make it something that's more attractive to folks. Quantifying ET in interception processes, I think, is a critical part of the consumptive water use story. Looking at multi-annual VADOS saturated zone water flow, long-term time series, and looking at water quality benefits. I've already been doing some water quality work, collecting data at the 2 sites, but didn't have time to discuss that today. But there's a great deal of need to look at that as well. Thanks so much. I'd be happy to field a question if there is any.
Questions for Jason?
Have you thought about planting any oak? Cottonwood and willow are fast growing and everything, but oak provides, acreage for wildlife. And there's a lot of oak species that, can tolerate quite big.
Yeah, I really like that idea. I will repeat that, yes. So the question is, have I or we considered reforestation of oak in addition to the other species? I would, directly no. Indirectly, yes. If we're looking at native reforestation, then I think that oak could play an important role in that. You raise a good issue. It's completely valid. I think that one of the benefits of this practice is the possible implications to wildlife and wildlife corridors. So yes, absolutely. It's a great idea. Rob?
So Jason, you made the calculation to show that transpiration can be, you've made the case that the calculations show that transpiration can be a significant number. Have you ratioed that to runoff from the entire basin so you get a sense of whether it's a significant number compared to what might be considered excess runoff? Yeah,
that's a great point, Rob. Thanks. No, we haven't done that. I think that's where the modeling needs to go next to take a better look at what you're getting at, which if I understand correctly is what is the actual benefit in terms of ET relative to total runoff. Isn't that correct? Yeah, so I think that to do a responsible job of that, we really need to do some in-depth modeling. And this stuff today that I've talked about, we haven't gotten there quite yet. Thanks.
One more question? Okay.
Hey, Jason, just a quickie. There's tree planting and there's tree planting. Are you doing anything like for weed control or deer damage or browse protection? You know, several different methods. As long as you're putting them out, maybe half of them you use weed control and see if they grow 10 times better than the other. You get better survival. So, I mean, there's some opportunities here, but so that's a long-winded question, but the point is just sticking a tree in the ground is not always just the answer. There's how and where and how do you maintain it or take care of it. Are you doing some of those steps in conjunction with sticking the willows in the ground? Or, as the gentleman back there asked about the oaks, you know, other alternatives that could be done.
I understand your question. Thanks, Scott. I guess I could tell you, let's see, what we're doing about that. Not much at the moment. I think that's a very important aspect that we need to look at. The issue has come up, and last year after we planted the willow site, one of those issues was weed control, and the solution was to mow the grass once a month. Because it is a floodplain, and the entities, the university, rightfully so, is concerned about those herbicides and so on making their way to the stream channel. And I think that's a legitimate concern, but I think there are smart ways to go about doing this, and I think that's area wide open for some research. As far as we did lose a number of plants to deer. I wasn't informed that there was a good-sized deer population down at the Willow site, and there happens to be a family or association, whatever it is, of about 10. So there you have it. Yeah, there are a number of issues like that need to be dealt with, and those are all your legitimate points. Much of this research is in its infancy, but I think we will be going that direction. Yeah. Thanks. I hope that helped. Yeah.